Assalamu alaikum ji. We will start the class now. It's about 8:10. Okay. So let me turn on the captions. Okay. So I am sharing my screen, and I hope everybody in the class can see the screen, my computer screen. Okay. So Bismillahir Rahmanir Rahim ji. Welcome to week 3 in steel structure CE 409. Okay. In this lecture, we are going to discuss the connections. Okay. Connections in steel structures are very important. Most of the steel structures failed at the connections. Okay, like the connections, steel structures failed at the connections because due to the poor design of connections or the poor maintenance of the connections. So mainly we will talk about two type of connections, okay, that we call eccentric connections and simple connections in this class or in this course. And the contents which will be covered in this class is shown on this slide. Okay, in this lecture, first we will talk about the type of fasteners. Okay, fasteners. What are the fasteners? Fasteners are the components which make up the connections, and we will discuss 3 different type of fasteners in this class. And you will see that those fasteners we call rivets, bolts, and welds. Okay, they are the fasteners. We will go through it shortly. Then we will discuss the behavior of bolted and riveted connections. Okay, now we will discuss that bolted and riveted connections behavior. We will not cover welds in this class. We will cover welds in the coming class. Then mostly we will talk about the bolted connection in this class and their design. Like what are the different types of the bolted connections. Okay, mainly you will see that there are 2 type of bolted connections. Please remember it. Okay, there are we call it bearing type bolted connection, we call it slip critical bolted connection. So we will go through their detail in this class. Then we will see that what are the different failure modes in bolted connection, like how the failure is possible in bolted connection. So we will see that there are 3 distinct mechanisms by which a bolted connection fail. Okay, then at the end we will have some examples on bolted connection, like what are the specification of American Institute of Steel Construction that you have to observe while designing or your connection. Okay, then we will go through example on shear strength, shear failure of the bolts. Okay, so there are some examples, and apart from the examples there are some problems in this lecture as well. So as I told you that we are going to discuss the type of fastener first. So there are 3 type of fasteners which make up the connection. Okay, like we call them rivets. We call them bolts, and the third fastener is welds. So they make up the, or they make steel connection. Okay, like connection, steel connection. Okay, so these fasteners make the steel connections. So we will discuss rivets. Please remember that riveting or rivet is an older technique. Okay, this is an older technique, and this is rarely used nowadays, and you can consider it obsolete now. Okay, but it is still being used in the aircraft industry. Okay, now the second is the bolting. Okay, now bolting is now it is a very popular technique. Okay, now people have shifted, or we have shifted from riveting to bolting. Okay, the reason why we have shifted to bolts is that it requires less skilled labor. Okay, less skilled labor, and it is rapid in construction. Okay, please remember this. So on the other hand, rivet requires skill labor. Okay, and it is a kind of permanent fastener. Okay, bolt, we have the liberty that we can unbolt two components and then we can replace bolts very easily. Okay, welds on the other hand, it's like we also use welds. So what is the advantage of using welds is that welds make welds make us a connection, steel connection, either riveted or bolted, looks simpler. Okay, so this is all about the fasteners. Like, you should remember that rivets are obsolete, like, but it's rivets worth studying, because most of the older structure, they have used rivets. Okay, rivet as a fastener at the steel connections. Okay, bolting is the way to go. Like, we prefer bolting and welding, and in this course we will cover these bolts and welds. Bolts we will cover in this class, we will try to cover in this class, and weld we will cover in the coming class. Okay, now you can see that this, in these three pictures, you can see that this, you can see if you have this kind of structures or joints in a structure, so you should recognize it, that this is riveting. Okay, this is riveting, and you can see that this is bolting, and you can see this is welding. So you can see that there are different steel structure members which are joined together with the help of these fasteners. So we know that in steel structures we have some definite shapes, hard roll shapes. Okay, we design for these members. Okay, but the problem is how to connect them. So in order to connect them, we use these fasteners. Okay, so do you remember what is the name of this shape? Anybody from the class?
W shape.
W shape, wide flange shape. What is this one?
Angular shape.
Yes, this is not angular, but we will call it angle. Okay, so when we design a tension member, or when we design a compression member or flexure member, so we have to select these shapes, but these shapes need to be connected. Okay, so they are connected by bolting, they are connected by welding, they are connected by riveting. So please remember that riveting is a permanent fastener. Okay, so bolting is like you can replace this bolt very easily. Okay, and the welding, the advantage of using welding is that it makes a bolted or riveted connection looks very simpler, and there is less quantity of steel is used in the welding. Okay, compared to bolting and the riveting. So now let's come to the type of fastener, like components which make up the complete structures. Like, components means that these shapes, okay, the same shapes I have talked about, that W shape or wide flange shape or the angular shape. Okay, now these members, you have to connect them, and you have to connect them with some type of fasteners, and there are three types of fasteners. Riveting, rivets, bolts, and welds. So riveting is obsolete now. Okay, please remember, this is obsolete. So we are not going to discuss riveting or design of riveted connection or analysis of riveted connection in this course. Okay, so we will just talk about the bolting and welding, and we will talk about bolting in this class and welding in the coming class. Okay, so you should remember there are three types of fasteners. Okay, rivets, bolts, and welds. So when we talk about steel connections, so as I told you that you have to join two plates or two members together, or you have to tie two members together in steel connections. In steel connections, oh sorry, steel connections, where is this one? Yes, my, in steel connections we have two type of joints, okay, we have two type of joints, and they are lap joints. Okay, and we may have butt joints. in our connection. Okay, so this is an example of a lap joint. And in lap joint, what happens that there is an eccentricity between the loads. So due to the eccentricity of this load, so there is unsymmetrical loading in a lap joint. Okay, so due to this unsymmetrical loading in the lap joint, what happens that it causes bending in this type of joint. So this type of joint is not suitable. It's only suitable for minor joints. Okay, minor loading. Okay, where the demand is very less. On the other hand, if you see that there is a butt joint. Butt joint is constructed with the help of three components. Okay, in butt joint we have symmetrical loading. Okay, there is no bending of members or local bending of the members in this type of connection. So in butt joint there is symmetrical loading, so you should always go for butt connection, butt joints. Okay, at your steel connections. Okay, is that okay with you? In this, we have unsymmetrical loading. In this, we have symmetrical loading. So try to go for this connection, giant, okay? Is that clear to all of you?
Yes, sir.
Good. Now, this is an example of a plate girder, okay? Now, you can see this image. So this is a plate girder, which is a built-up sections, which have been constructed or fabricated by joining different plates. So this, you can see that this plate girder section has been fabricated with the help of rivets. And this, the same plate girder, which is fabricated with the help of welds. So you can see that in case of rivets, there is a lot of steel which is consumed for making out the same connection, the same member or section. So riveting consumes more steel, or bolting consumes more steel as compared to welding. Okay, and aesthetically, welds also looks good. Okay, like as compared to this riveting. So this was just I included this slide to explain that, like what will happen if you go for a riveting, what will happen you go for a welding. So welding looks, there is a good aesthetic look of the member, and at the same time you save a lot of steel compared to riveting. Okay, now as I told you that rivets are now obsolete. Okay, but rivets are still important because for strength and rehabilitation evaluation of older structures. And how rivets are made? Rivets are made from rivet bar, which are stock in a machine, which forms one head and shears the rivet to the desired length. In a simple case, a rivet consists of one head and the body. We call it shank. Okay, this we call shank, and this we call head. Okay, now you have to drive this rivet into the hole. Okay, and on the ones but you carry out this operation when this riveting is made red hot, or it is heated before driving it into the hole. Okay, so steel rivets are always heated before driving. You have to drive it. Okay, so heat it before driving it in a joint. Okay, now most rivets are driven by pressure type riveters, which complete riveting in a one stroke. Okay, now rivets are made of two steel material, and they are made from a steel, please remember, ASTM 502, which comes in two grades. Grade 1, which we call carbon steel. Grade 2, carbon manganese steel. Okay, so remember that rivets are made from ASTM A502. Okay, and then we have grade 1 and grade 2. Okay, there are different type of rivets, like we have round head rivet. You can see this is an example. This is a picture of a round head rivet. We have counter shank rivet, okay, the one with have where minimum or with it does not have a rounded head, okay. So this is called counted shank rivet. There are other type of rivets like apart from the counter shank rivets, we have flat head rivet, we have universal head rivet, we have rounded head rivet. If there is a space availability issue to this side of the member, then you go for counter shank rivets, okay. So let me explain now how riveting is carried out. For example, if I go for a joint, I want to connect two plate members. So what will happen that, okay, once what you do, you drive a rivet, okay. It is a rounded head rivet, okay. What you do that you drive that rivet into the hole which is being made in these two members, okay. So it is so that it is the length of this rivet is more than these two plates. So what will happen that this is heated, okay. This is in the heated, okay, or you can say heated state or hot state, okay. What happens that when you drive this rivet into this plate, so this portion is flattened with the help of a gun, so it becomes, it is converted to this shape, okay, while it is still hot, okay. So what will happen that when it is in the when it starts cooling, so what will happen, it will shrink, and when it will shrink, it will apply clamping force on these surfaces, okay. So these clamping forces are responsible for holding together these two plates, okay. Is that clear to you now?
Yes, sir.
समझ आ की जो स्टेट है ना, दिस इज हीटेड, ओके। आपकी जो रिवेट की लेंथ है वो इससे थोड़ी सी ज्यादा होनी चाहिए, और वंस यू दिस इज स्टिल हॉट, यू कैन फ्लैटन इट, दिस पोर्शन इज फ्लैटेंड, ओके। एंड when this rivet starts cooling, what will happen that it will start shrinking, and when it shrinks, so it applies a clamping force along the fang surfaces, okay. So riveting, like as I told you that you have to heat it up before driving it into the connection. So you can see in this picture that rivet it heated, okay, here. And riveting is carried out with the help of riveting gun, okay. So this is an older version of a riveting gun, and this is a modern version of riveting gun, okay. So in riveted connections, the magnitude of clamping is a function of the length of rivet and the magnitude of the shrinkage after the heat is formed. So the same thing like that, as I told you that rivets are still hot when they are driven. So when they starts to cool, okay, start cooling, what will happen that they will apply uh, a clamping force, okay. This clamping force is a function of what? Shrinkage in the rivets, okay. Now the magnitude of the slip along the joint which is made by riveting depends upon the extent to which rivet fills the hole, okay. Now riveting is obsolete because I told you that riveting requires skill labor, okay. Riveting required a crew of 7 to 5 experienced riveters, okay. Now, on the other hand, we have shifted from riveting to bolts. Bolts installation is less labor intensive as compared to rivets. So, riveting is time consuming operation requiring preheating, driving, and finishing. Okay. So, that's why we have now shifted to the bolting. So, rivet strength is always lower compared to the high strength bolts. Okay. High strength bolts are now economical, they are easily available in the market. Okay, riveting is still used in some industry, and especially their application is still going on in the aircraft industry. Okay, now let's go to a video so that will explain that how riveting is done. Okay, just give me a moment. Okay, yes, now, yes, watch this video. Is that clear to you, like how riveting is carried out by watching this video?
Yes, sir. It's too easy.
Okay, thank you very much. Any question from your side? कोई सवाल है? किसी का
No,
कोई
sir.
सवाल? Okay. Okay. Now, when we talk about steel connections, okay, steel connections means like steel connections are formed by three types of fasteners. We discussed that. Rivets, bolts, and welds, okay. Now, in this slide, you will see that what are the different forces which are acting through the connection. Like the first scenario is that, like over here you will see that I have added some sketches or pictures which are referring only boards, but it does not mean only boards. You can just, we can write it here like just give me a minute. We can write it here, it can be welds as well, welds and boards. Okay, they are applicable to both welds and boards. Okay, so The welds and bolts, like through a connection, may be subjected to shear forces. Okay. Or this is an example, like this is an example of a simple connection. Okay, as I told you that there are two type of connections, so I'm going to explain that. Okay, if the force or applied force or resulting force passes through the centroid of a connection, so we call it a simple connections or concentric connection. If the resulting force is not passing through the centroid of the connection, then we call it eccentric connections. Okay, so eccentric connections we will not discuss. Okay, they are not part of your course. Okay, so we will not discuss that. Okay, so the what I was trying to say through this slide is that connections can be subjected to shear forces. They can be fast connections can be, or fasteners can be subjected to tensile forces. Like this is an example of a hanger. Like you can see that the applied force is in the downward direction, and we have these two fasteners. Let's consider them as bolts. Okay, so they will be subjected to tensile forces. Okay, similarly the connections or the fasteners can be subjected to shear forces. So different design procedure is for the when you have this type of scenario, the design procedure is different. When the you have this type of scenario, so you have a different design procedures. And obviously when you have a combination of shear and tension acting on your connection, so then we have a different design procedure. Okay, in this class we will be focusing on this scenario. Okay, so as I told you that we have shifted from riveting to bolts. So there are two type of bolts. So they are called unfinished bolts or low ordinary bolts. Okay, so they are designated as A307. Okay, A307 is known by the names unfinished. We call them rough bolts, common bolts, or ordinary bolts. Okay, so they are made from low carbon steel, and they have a tensile strength of 60 ksi. Okay, on the other hand we have this unfinished bolts. Okay, let me write it down here. We have this unfinished bolts. Okay, and we have this high strength bolts. Okay? High strength bolts. So unfinished bolts, they are designated as A307. High strength bolts are designated as type A or type B. Yeah, type B. Okay. In type A, we have this A 325, A 490. Okay. So please remember that we have two type of bolts which are being used in steel connections. Okay. Unfinished bolts or high strength bolts. So high strength bolts, they are designated. I told you that they will be designated in some books or some literature as type A. When we say type A means A25, and type B, okay, which is A490. Okay, so high strength bolts, they are made from medium. For example, A23 bolts are made from medium carbon steel whose tensile strength decreases with increase in their diameter. Okay, so high strength bolts can be tightened to a large tensions. Okay, as compared to the A307 bolts. Okay, so what is meant by this statement? It is let me draw the same joint again. Okay. Okay, this one. What is the name of this joint? इसका क्या नाम है इस joint का?
Lab joint, sir.
Yes, thank you very much. अच्छा, what happens is that you have a head. Okay, you have a body. Okay, which is threaded. Okay, threaded, and you have this nut here. Okay, so what happens that once you tight the nut, okay, so you do it with the help of wrench, okay. So what happens that there is pre-tensioning that is introduced to this bolt, and as a result of this pre-tensioning, we do it with the help of torque, okay, torque. We apply certain torque to tension the bolts, okay, or pre-tension the bolt. So what will happen that once you it will apply a clamping force, okay. This is the clamping force. Once you pre-tension the bolt, this clamping force will act, or this will be generated, or this will be produced along these fang surfaces. So these surfaces are known as fang surfaces, okay, fang surfaces, okay. So if the strength of this bolt is higher, so you can produce more tension in the bolt, and as a result you will get higher clamping force along the fang surfaces. So this is meant by this statement. Is that clear to you now, that why we use high strength bolts?
Yes, sir.
Okay, thank you very much. Now, this is a simple picture. How does a high strength bolt or symbols bolt look like? Okay, so it can be either A325 or it can be either A490. This is type A, okay, and this is type B. Okay, what is this? Okay. So simply it consists of a head, it consists of a nut and a washer. Okay. So as I told you that once we apply tensioning or tightening to we tighten the bolt, what will happen there? There will be clamping forces that will be produced along the fang surfaces, but there are different procedures, okay. The Research Council on Structural Connections prescribes 4 tensioning procedures for high strength bolts, okay, which is there are 4 procedures. Like first procedure is turn of the nut method, okay. Then we have that calibrated wrench tightening. Then we have installation of alternative design bolts. So then we have direct tensioning, indicator tightening, okay. Okay, so there are different procedures, okay, which are prescribed to pre-tension the high strength bolts, so you can get the clamping forces along the fang surfaces, okay. So please remember that. So at tightening, basically you need a torque range, okay, so which is graduated, so you can apply a specific torque to a bolt, okay, in order to get the clamping forces, okay. Then we have the direct indicative method of tightening, in which you have this washer, okay, and there is a specific gap between the bolt and this washer, okay. Once you start tightening the bolt, okay, so this is in this state we call it snug tight condition, okay, snug tight condition of bolt, snug tight up. Okay, this is not pretension then. So what you do, you apply the torque. So what will happen that this gap will be reduced, and this gap is a function of the torque, okay. So it can indicate that the bolt which is found in the field is tightened, or it is already tensioned, okay, pre-tensioned, okay. This is before the tensioning, this is after the tensioning, okay. So this is direct tensioning indicating washers, okay, of the tensions. Now we will come to the behavior of connectors. Any question? Any question from your side?
No, sir.
Let think about it. Okay, you can take 3 to 4 minutes to think about it. Any question, कोई सवाल हो आप पूछें, अगर समझ नहीं आ रही आप मुझसे पूछें तो मैं उसको हो सकता है आपके सवाल का जवाब दूं तो चीजें क्लियर हो जाएं आपके लिए।
एक्सक्यूज मी सर।
जी
सर ये स्नग पे जरा दोबारा समझाएं।
हाँ, स्नग टाइट कंडीशन ये है कि देखें आपने एक बोल्ट लिया, ठीक है, बोल्ट है, आई एम सॉरी फॉर माय ड्राइंग, ओके, व्हाट इज द डिफरेंस बिटवीन अ बोल्ट एंड अ रिवेट? रिवेट का क्या होता है कि द शैंक और द बॉडी इज नॉट थ्रेडेड, बट इन केस ऑफ बोल्ट दिस इज थ्रेडेड, ठीक है, एंड ओवर हियर you have that nut, okay. For example, you have installed a bolt, okay, and you have placed the nut, okay, and you have placed the nut in a such a way that you cannot replace it or you cannot unscrew it without the help of the wrench, okay, like snug tight condition, snug tight condition when the net, okay, the nut, I'm sorry, this is the nut is, oh, it cannot, pocket cannot be removed by a wrench. This condition we call snug tight, okay. From snug tight conditions, what you do, you apply the torque, okay. snug tight condition आपके पास आ गई, इसका मतलब है कि no tensioning is applied, ठीक है. And what is snug tight condition? This is the snug tight condition. Is that clear to you?
यस सर।
अच्छा, चलें, मुझे पता है आपका रोजा भी है, ये बताएं कि लैप जॉइंट में सिमेट्रिकल लोडिंग होती है कि बट जॉइंट में? बट जॉइंट में सिमेट्रिकल लोडिंग होती है, सो यू विल प्रेफर अ बट जॉइंट ओवर अ लैप जॉइंट, ठीक है.
यस सर।
अच्छा, बोल्ट्स की कितनी टाइप्स होती हैं?
4।
नहीं 4 नहीं, 2. A307 which are known as unfinished bolts, okay.
यस सर। एंड हाई स्ट्रेंथ बोल्ट्स।
Yes. और फिर you have A23-5 or A490. These are the high strength bolts, okay. ठीक है जी. This you will see that in example or in books, this is now designated as type A, this is now designated as type B, okay. ये बताएं why riveting is obsolete now?
Sir, it needs skilled labor and
Skilled labor
yes sir, and more steel is required.
for the connections, okay.
Yes sir.
Good, ये बात भी ठीक है. More steel is consumed. Is consumed. ठीक है. What is the time now? Can we take a break for 5 minutes?
Yes sir.
Yes,
चलें,
sure.
आप लोग सोचिए, ठीक है, 5 मिनट मैं भी जरा आराम करता हूँ, ठीक है. So we will start with discussing behavior of connectors after the break, okay. In the meanwhile, अगर आपके दिमाग में कोई क्वेश्चन है तो आप सोच लें, then we can discuss those questions. सबको क्लियर है कि सिर्फ आपको क्लियर है?
सर आई थिंक सबको क्लियर होगा सर, आसान है.
चलें, then let's take a break for 5 minutes, okay.
Okay sir.
Okay. अच्छा जी, आवाज आ रही है मेरी आपको?
यस सर।
ये बताएं कि टाइटनिंग टेंशनिंग प्रोसीजर्स कितने हैं?
4।
अच्छा, are they for this, what kind of bolts, like they are for this type of bolts?
यस सर।
No, they are unfinished bolts, they are for high strength bolts. Okay, A 325 and A tightening procedures are for high strength bolts. Any question from the rest of the class?
नो सर।
मैं जरा क्लास में तो देखूं कि क्या है, कितने लोग हैं। आप लोगों को सबको समझ आ रही है?
यस सर।
चलें
Yes, sir.
चलें, थैंक यू। जब आप बोर हो जाएं या थोड़ा सा थक जाएं, आप मुझे बता दें तो मैं वहां पे ब्रेक ले लिया करूंगा, ठीक है? Okay, we will start over again. Okay, now we will discuss the behavior of connectors. Okay, in behavior of connectors, so we will first talk about the behavior of bolted and riveted connections. Okay, so as we discussed that, I will try to explain it with the help of, again, I have to draw a lap joint here. Okay, so let me draw a lap joint. Okay, so a lap joint is, let's say, okay, this one. Okay, I'm not drawing the fasteners. Okay, so let me draw a fastener. I hope this will be clear to you. Okay, once you apply, like what happens that we have a clamping forces here. Okay, once you apply the tightening, so what will happen that there will be some clamping forces. Okay, that will be produced, and in addition to the clamping forces, we will also have this type of forces. Okay, frictional forces. So once you apply the clamping, so apart from the clamping forces, we will also have frictional forces which will be acting along the fan surface. Okay, so the magnitude of the frictional forces is mu times clamping forces. Okay, mu is the friction coefficient. Okay, now in this slide you are seeing that there is a joint. Okay, and to this joint a load is acting on this joint, and a displacement is produced on this joint. Okay, on y-axis we have this load which is acting on the joint, this load. On the x-axis we have this displacement. Okay, along the joint, and in this joint it is possible that you have the bolts and rivets. It is applicable to both rivets, connection with rivets, and connection with bolts. Okay, what happens that when the load is applied, okay, when the load is applied, what happens? So this load is first resisted by these fractional forces. Okay, these fractional forces, that they resist the load first. Okay, like let me this one. Okay, so once they overcome the frictional forces, what happens that there is a slippage. Okay, there is a slippage. Now then this fastener comes into contact with this bolt surface. Okay, this surface, this surface, this surface. So it gets engaged at this surface with these plates. Okay, what will happen that first there is a slippage. Okay, slippage, the force is resisted by the frictional forces, and then the load is resisted by this bearing action. Okay, once it reaches here, what happens that, let me draw it here. For example, this is bolt number 1A, sorry, bolt B and bolt C. So once it reaches here, okay, what happens that the forces along the second bolt or rivet, so these friction forces again comes into play, okay, like this. So the frictional forces will resist the applied load, okay. So once the slippage occurs again, so it will again shift to this contact between the plates and the fastener. So you can say that the resisting behavior or behavior of bolted or riveted connection consists of two type of mechanism, like frictional force, so, and the clamping force. पहले क्या होता है कि frictional force is exhausted, the fastener becomes, or it engages with the plate, and this connection becomes a bearing type connections. Once the load is at the connection is resisted by frictional force, we call such connection, slip critical connection. Slip critical connections, okay. Once the fastener gets engaged with the plate itself, so again it resists the load, okay, due to the bearing, okay, bearing of the fastener onto the plate. So this type of connection we call it bearing type connection. So obviously these two behaviors have been explained on this graph. First, the load is resisted by the frictional force, okay. Once it slips, so then it becomes a bearing type connection. Is that clear to you?
Yes, sir.
Yes, sir.
देखिए पहले क्या होता है कि frictional force resist करती है. So if the frictional force resists the applied loading, so this type of connection we call slip critical connections. Like there is no slip permitted, but जैसी slip खत्म होती है, the fastener gets engaged with the plate. So this connection becomes a bearing type connections. Bearing type connection का क्या मतलब है कि the load is resisted by the contact of this fastener with this plate. Okay, is that clear? This is A.
Yes,
This
sir.
is okay. So this is now in riveted connections. This is where we have already studied that in riveted connection, the magnitude of the function of the length of the rivet and the magnitude of the shrinkage after the head is formed. Okay, कौन सी head की मैं बात कर रहा हूँ? इस head की बात कर रहा हूँ. Okay. Second head, this head. When this head is formed, so shrinkage is produced in the rivet. So as a result of the shrinkage, clamping force will be produced. Okay. So types of bolted connections. So as I told you that there are two types of bolted connections. Okay, two types. Okay. First type we call it slip critical connections. Slip critical connections, forces are transmitted by friction produced between the fang surfaces by the clamping action of bolt. किस चीज की बात कर रहा हूं? इस चीज की बात. We are talking about this frictional force. Okay. So the load is transmitted by this mechanism. Okay. Slip critical connections are recommended for joints, for those joints which are subjected to stress reversals or severe stress fluctuation or impact or fatigue. Okay, so slip critical connections are used mostly in bridges where you have fatigue, okay, or load reversals. Okay, in slip critical connections, slip is not permitted. If there is a slip in the connection, if there is a slip in the connection, so connection is assumed has failed. Okay, now this slip critical connection, जैसे इसमें slip आ जाएगी, what will happen? It will be converted to a bearing type connection. Okay, there are two type of connections: slip critical connections and bolted connection, and the second is the bearing type connection. Okay. Okay, now the clamping force is applied to bolt that bring two member close enough so that appreciable friction is produced between them, which is then responsible for resisting the load. Okay, the more the clamping force, more is the friction and strong is the connection. Okay, but the clamping force need not to be greater than the tensile strength of the bolt. Okay, what is the tensile strength of the unfinished bolts? What is the tensile strength of A307 bolt?
KSI.
Okay. Okay. What is the tensile strength of type A bolt? This is about 120 KSI. Okay. So if you tension it more clamping forces will produce. If more clamping forces will be produced, so what will happen? It will produce in turn more fractional forces. Okay. So the clamping force, like you have to apply the torque. You can apply a torque up to the 70% of the tensile strength of the bolt. Okay. Up to. You can say the clamping force is up to this much. Okay. Slip critical connections. Please remember, slip critical connections become bearing type connection after slippage occurs. So every slip critical connection is essentially a bearing type connection. Okay, is that clear to all of you?
Yes, sir.
Okay. So okay, what happens in bearing type connection? Okay, in bearing type connection, load is transferred by the shearing and the bearing on the bolts. Okay, capacity in shear depends on whether the shear plane intersects the body of the bolt or the threaded portion of the bolt. Okay, if for example this one, this is the shear plane. Okay, if this shear plane passes through the body of the bolt which is not threaded, okay, so the capacity of the bolt, oh my god, just capacity, oh my capacity, I have to write it, capacity is high. Okay, once it passed to the body, through the body, if the shear plane passes through the body, if the shear plane passes through the threaded portion, then the shear capacity is considered reduced. Okay, okay, clear? क्लियर है? Is that clear to all
No,
of you? नहीं
no,
नहीं,
sir.
अच्छा एक सेकेंड मैं बताता हूँ आपको. I will have to go to key. I will add a new slide here. Yes. Okay, let me draw a lap joint again. Okay. This is a bolt, okay? So this is a bolt like this. I'm sorry for, over here we have threads, okay? The shear plane will act through this portion of the bolt, okay? Shear plane or shear forces, okay? Shear plane that intersects the bolt passes through the unthreaded, I hope the spelling is right, unthreaded portion of the bolt. Okay, this is case 1. Okay, now case 2 is if the shear plane passes through the threaded. I know. Can you please check what is the spelling of threaded?
THREADED.
T H
Yes, sir.
R
REA.
T E D. Okay. So you have to write this H here. Okay. Portion of the bolt. There are two cases. If the shear plane does not pass through the threaded portion, if the shear plane pass through the threaded portion. Case 1 is that shear plane passes through the unthreaded part of the bolt. So shear capacity, I'm sorry, shear capacity of the bolt will be higher for case 1. For case 2, shear capacity or the shear strength of the bolt will be reduced. And who says that if the shear plane passes through the body and if the shear plane passes through the threaded portion and the shear capacity will reduce? This specification, which is AISC, it tells us or it recommends or it directs us, if this is the case, you have to use, it is the full capacity of like the it will resist more shear force. And if if it is the case 2, so the bolt will, the shear capacity of the bolt will be reduced. This is according to AISC specification. Okay, is that clear to you now?
Yes, sir. It's clear now.
Achha. Okay, bearing type connection is the most widely used journal type of connection in which the load is resisted by the bolt body through shearing, okay, without any friction between the flaying surfaces. In bearing type of connection, there is no, it is assumed that there is no frictional forces along the flaying surfaces, Okay. Okay, now this brings us to the types of connection failure. In bolt, I'm talking about bolted failure, okay, bolted connections, okay. So there are three type of failures, okay, and this is about the bearing type connection. Slip critical, we know that once slip is permitted or there is slip occurs in the connection, we assume that the connection has failed, okay. Slip critical is converted to bearing type, okay. This is bolted connection types, okay. So there are three type of failures which you should expect or which can occur in the connection. That can occur in the connection we call shearing failure of the bolt. The bolt can fail in shear. There can be failure of the connected plates or connected components of steel structures, steel component members, okay. Bearing failure of the plate. The third is the tearing failure at the edge of the plate. This is due to bolt or fastener. This is due to the connected component. This is, you can say, you can attribute it to failure of connected component. We have two types, tearing and bearing failure. One, this is the failure of the bolts. So these three type of failure can occur in a bolted connection, okay? And that bolted connection is bearing type connection, okay? Not slip critical connection, okay. Now this is now you can see that how a bolt can fail in a bearing type connection. Like for example, this is a plate, this is a lap joint, there is a force acting. So what will happen that the bolt is weak in shear. So what will happen that bolt will fail in shear at this location, okay. Now this is the failure of the bolt, okay. Shear failure of the bolt. First. The second, this is a butt joint, okay. Now this is shear failure of the bolts, but this shear, okay, just remember, in case of lap joint, okay, in case of lap joint, there is one shear plane, okay. In case of butt joint, there are two shear planes or shear failure planes. Shear failure plane. So you can see that there are three plates. Failure can occur here, failure can occur here. So we term it, whenever we have this type of situation, we term it double shear. The bolt is subjected to double shear, okay. That bolt is subjected to double shear. In this case, we term it the bolt is subjected to single shear, okay. And what is the area of the bolt which is being used, okay, for computing the shear strength of the bolt? This is very simple. AB is equal to the diameter times this one. So in case of single shear, this formula you can use, okay. So in this case, what you have to do is that you have to multiply it with 2, and this will become pi, I'm sorry, pi d square by 2. So when you have this type of situation and you are computing the shear strength of bolt, so you will use this formula in order to compute the area of the bolt. Okay, and if you have this type of situation, you will use this formula. Okay, this formulation you have to use. Is that clear to all of you?
Yes, sir.
Okay. Now the next is the failure of the plate. Okay, now you can see that there is a plate which is under the action of a tensile load. What happens that this fastener comes into the contact with the plate, and you can see these undulations. This is an indicative that the plate has failed. Okay, the plate has failed due to the bearing pressure exerted by the bolt onto the plate. Okay, so in this case the bolt will not shear. Okay, the plates will be moved. Okay, bolt will be intact. Okay, so you can see this green part. Okay, like the plate has failed in bearing. Okay, now what happens that sharing and bearing. Okay, now this is sharing. Okay, this is just a comparison between the bolt failure and the failure of the plate. Okay, the two cases we have discussed already. The third type of failure in the plate, it is not due to the bolt, it is due in the plate. This we call sharing failure of the edge plate. Okay, this can fail. Okay, this can tear. Okay, you have tearing failure at the edge of the plate. So this distance should be specified, and this has already been specified by the code, the minimum distance. Minimum, sorry, the minimum distance. The minimum distance. Okay, so in order to avoid the tearing failure, there should be a minimum distance between the bolt and the edge of the plate. Okay, and this has been specified, if I remember, for 7 by 8 bolt. If the bolt you are using a high strength bolt, ordinary bolt, if the bolt diameter is this one, this much, so this distance should be this much. So in order to avoid this tearing failure, okay, so we will see that in a moment. So now this in slide you can see that the bearing pressure or the bearing area. As I told you, in the bearing type of connection, the fastener apply bearing pressure onto the plate. Okay, this plate, this. And how you can compute this bearing area? You can simply multiply with the diameter of the bolt with the thickness of the plate. Okay, so this is here, this pressure. Okay, this is hole. I guess I have to check, is it hole or is it the diameter of the bolt? Okay, now this is showing the bolt failure in a single shear type. Single shear, this is double shear, this is a lap joint, this is a butt shear, this is a bearing failure of the joint. Okay, now this is explaining the tearing failure. Okay, like there is a specified distance from the edge to the centroid, and we call Rn as what? The bearing strength. Okay, and we call this distance from here to the centroid of the hole to the edge of the bolt, we will term it as Le. I'm sorry. Yes, LE. Okay. Now this Rn is equal to, I think, 1.2 dTFU. You should know the diameter, you should know the thickness of the plate, okay, and you should know the ultimate strength of the material. For example, if we are using A36 steel, what is the FY value for this type of steel?
36 K size.
Okay, what is the FU?
Sir, 50 to 80.
No, 58 KSI.
Oh, sorry, 58.
So you should know the material, steel material, okay? You should know the diameter, you should know the thickness, and you should know the ultimate strength of the material, okay? So this equation is given like this type. Okay, this slide is showing the bearing strength. How you can compute the bearing strength? This formulation. This is given by AISC, bearing strength. In order to evaluate the bearing strength, you should use this formulation. 1.2 into LC. I forgot to write LC. This is LC, I'm sorry. LC, what is LC? LC is the distance of the edge from the edge of the plate to the edge of the hole. You have to evaluate the bearing pressure which is exerted by this fastener, okay? So you can evaluate it using this formulation. And at the same time, you have to evaluate the bearing strength in between the connectors as well. So you will use this equation for this part, and you will use this equation for this part. You have to check the both edge distance and in between the connectors simply. So center to center distance of fastener is specified by AISC, okay? This is also recommended by this AISC, okay? So this distance between the fastener center to center should be, there is a thing, a number I have missed. This is 2/3 of D. What is D? Diameter of the bolt, okay? Or most of the time it says that it should be equal to 3D. Center to center distance between the fasteners. Okay, what is LE? In order to avoid the tearing failure, LE is the distance from the centroid of the bolt to the edge of the plate. Okay, this one, and this one. And in order to get this minimum distance, you have to go to table number J3.4 in AISC. And I know you guys cannot go to this specification. So this is there. This is here in this slide. This is that table. If the bolt diameter is 1/2 inch, LE should be at least 3/4 inches. If the bolt diameter you are using is 1 inch, so the distance LE should be 1/4 inches. Okay. If the bolt diameter is more than 1/4, so the minimum distance should be, this is LE. Okay. This is not LC. Don't get confused. LE. This distance. This is LE. LC is used for evaluating the bearing strength. That is LC. Okay. Any question?
No, sir.
Is that clear to all of you?
सर ये एस की वैल्यू जरा दोबारा बताएं इसकी सही समझ
किसकी?
नहीं
FU की?
सर एस की
S. Okay. Let me say. Just give me a moment. Okay. Just give me a moment. I will add a new slide. I will explain it here. Don't worry. Okay. Okay, I will try to draw a connection. I'm sorry for my drawing. Achha. For example, this is a connection. Okay. Okay, this one. And it is connected to this plate. Okay. With the help of bolts. According to AISC, this is S, center to center S. Okay. The minimum distance S should be always greater than or at least equal to 2 multiplied by 2 by 3 diameter of bolt, or 3, you can say, mostly we go for this one, 3 dB. Okay, this edge distance is LE. For LE, you have to consult a table. J, let me, J 3.4. LE is a function of dB. dB, remember, is the diameter of the bolt. You just have to consult that table. Okay. This edge to edge distance, this edge to edge distance, this distance is LC. This distance is also LC. In order to evaluate the bearing strength, okay, so that the plate may and should not fail in bearing, you have to evaluate this. Rn is equal to 1.2 LC into T into Fu, and there is an upper limit on this equation. It should be always less than 2.4 dt into Fu. Fu comes from type of material. Okay, for A36 steel, Fu is 58 KSI. For example, it will be given that this plate is made of A36 steel. This is also made of A36 steel. If this plate is made of another steel, so Fu value will be different. Okay. Now, this equation you have to apply here. You also have to apply it here. This bolt will exert pressure to this side if the load is acting in this direction, like this. And this will also be exerting pressure. Okay. So you have to evaluate bearing strength here and here using this equation. So you have to carry out all these operations for this plate. Okay. And this, say this is number 1. This is number 2. Let me draw again the lap joint. Okay. Okay. Two fasteners. Okay. Two fasteners. Here and here. This is number 1 material. Number 1. Okay. It's A36. Number 2, it can be A242 or A36. If both are made of same material, so their calculation will remain the same. If the thickness of this plate and thickness of this plate is the same, you have to do one round of calculation. If thickness of this one is different and 2 is different, then you have to do this operation twice. And we will see that in an example. Okay? Is that clearer to you now?
Yes, sir. It's clear now.
Okay, great. So what is the time now?
9:34.
Can we take a break?
Yes, sir.
Is that okay with all of you?
Yes, sir.
Yes, sir.
Let's take a break for 15 minutes, okay? When we come back, we will start discussing this example. This is, believe me, very simple, okay?
Okay, sir.
Okay. Okay, what is the time? How many students do I have? Okay, one student I have lost. Okay, there were 22, now they are 21. So I'm stopping the recording. Okay, I'm stopping.